Hello, Professor. This is my topic 8, DQ2 presentation. I'll share my screen to explain my codes. Now I share the screen. Share. Okay. For this assignment, what I have here is how to use exploratory data analysis techniques, but exploratory data analysis, EDA technique, could uncover patterns or relationships in data that are not immediately apparent by summarizing main characteristics of a dataset, often with the help of visualization. Also, EDA can assist with identifying and removing outliers in the dataset. The identification of outliers could be done through methods like Z-score, IQR, or visualization techniques. EDA helps to understand data distribution, correlation, and patterns. It could identify trends in time and space, creating hypotheses and testing them through experiments, as well as generate insights to guide for analysis. And this is the example of my data set here. I use a data set about apples, which includes details about the fruit size, weight, sweetness, crunchiness, juiciness, ripeness, acidity, and quality. The approach used in EDA to find hidden patterns or relationships include descriptive statistics, here, that I have here, descriptive statistics, to calculate summary statistics such as mean, median, and standard deviation. Also for data visualization, there's creation of a box plot. I created the box plot there. And that box plot checks for outliers. And there are checks here also for missing values. I check for missing values here. And I got one except for acidity. And what I did here too, I dropped the rows with the missing values. That's how I clean my data. And I check the acidity column. The acidity column had text instead of numbers. And that column here was dropped, and this is displayed here. And for quality, quality had good or bad, and it was changed to binary. And I have the good amount as 1027 and the bad amount as 995. Then I did the statistics again after I changed those two, and I got these values. Now, the box plot here shows there are much outliers present. And I did the IQR method to remove these outliers. And here, it's cleaned. Now I did the correlation analysis. After the outliers are removed, these are my codes. And I have the heat map here. And with this heat map, it shows the various features against the quality that was now encoded. And the visualization helps to identify patterns and relationships between the quality, size, weight, sweetness, crunchiness, juiciness, ripeness, acidity in the apple data set. And if we look here at the size against the quality and encoded, it's 0.25. And this indicates a weak positive correlation between the size and the quality encoded feature. And this positive sign here, it's positive. This one here is negative. This one is positive. This indicates that size increases, the quality encoded tends to increase as well, but the correlation is not very strong because it's not very close to 1. And the correlation coefficient close to 0, this is closer to 0 than to 1, it shows that it is a weak correlation. I also did these plots here, the histogram plots, and the curve are almost bell-shaped. And this means that, okay, let's look at this example with size against count. It shows it's bell-shaped, it's roughly a bell-shaped curve, which suggests that size follows a normal distribution. Now, the next part of the assignment is how can Python be used to develop a useful tool in this context, where Python uses libraries such as pandas, matplotlib, and seaborn to develop a useful tool in the context for analyzing and visualizing the data loaded. The Python could create scripts in the Jupyter Notebook and condenses common data analysis. The tool could permit the loading of the dataset, explore its basic information and summary features, as well as visualize the correlation heat map for specialized numerical features and the target column. So that is what my code is, and I stop sharing the screen. Thank you. That was my presentation.